Laptops and notebook computers. So we're all familiar with what those are. They're basically small computers you can take with you, right? These things started out originally developed for a niche market. It was basically made for business travelers, and they were very, very expensive. Nowadays, they're actually cheaper than most desktop computers. They're widely used by businesses. They're widely used by consumers. As I look around the room, we have several laptops just sitting in this room alone. We have laptops, notebooks, netbooks, and even tablets that fall into this category. The big difference between a laptop and a notebook and a netbook is size, weight, and performance. Netbooks are very small, they're very light, and they have very low performance. You go into something like a laptop, they tend to be bigger and bulkier. Those are those gaming laptops that are 17 inches big, right? You look at a notebook, they tend to be around the 13-inch to 15-inch screen size. Tablets tend to be lacking in keyboards. They're all touchscreen, like an iPad or a Surface tablet, and they can actually hook up to a keyboard to turn them into a laptop if needed. Laptops are just like your regular computers. The big difference is they're expanded differently. We can't fit a PCIe X16 card into a laptop, right? It's just physically not going to fit. So instead, we have to expand them differently internally with the components. And any kind of upgrades we're going to do are going to be performed just a little bit differently. So we'll talk about those as we go through here. The big difference here, we're going to use the same kind of components, right? We're just going to want things that are going to be better for battery life, which means they're going to be less not as good performance-wise as a typical desktop, generally, or we're going to sacrifice battery life for performance. The first type of expansion slot we're going to talk about is what's called PCMCIA, which stands for Personal Computer Memory Card International Association. You don't need to remember what it stands for. Just when you see the word PCMCIA on the exam, think laptop expansion, okay? Instead of putting in a PCIe card, we're going to use this PCMCIA card. They're little cards like I'm showing you here. Down here is a USB expansion card for USB 2.0, and it would just slide into the side of the machine until it clicked into place. We have PC cards, which are 16-bit, and card bus, which is 32-bit. The card bus, you could tell that what they are because they have this golden edge to them instead of the silver edge. They're hot swappable, so you could take them in and out while the laptop is running. They have a 68-pin connector, and there are 2 rows of pins making up that 68 pins, 34 pins each. They're classified as either Type 1, Type 2, or Type 3. Type 1 was used to actually upgrade the memory. We don't do this anymore. This is from the 1980s style stuff. Type 2 is used for input-output devices like modems and networking, and USB, and they were 5.5 millimeters thick. And Type 3 is actually double size that. It's 10.5 millimeters thick, and it is upgraded Type 2, giving you more data transfer capability. Most laptops nowadays aren't really expanding through PCMCI though, especially if you want to add something like USB. Most of the time, you're just going to hook into a USB port on the laptop, and you're going to use a hub to do that. You're not going to put in a PCMCI card for that. The most common PCMCI card that I see is something like a cellular modem, but even those have pretty much converted into thumbsticks at this point, not using a PCMCIA card. The upgrade to the PCMCIA card was the Express card, which again is another form of expansion for laptops. They come in 2 different sizes, either Express card 34 or Express card 54. And what that number means is physically how wide is the card. Is it a 34 millimeter card or a 54 millimeter card? And you can see that here on the bottom size, where the one all the way on the right is 34 wide, and the ones on the left are 54 millimeter wide. If you have a 54 slot, it will fit a 34. A 34 will not fit a 54 though, it's too big. The Express cards use PCIe as the internal bus, or they use USB on the host to communicate with the chipset, and that makes them much faster than the old PCMCI cards. Just like we expanded and went from PCI to PCI Express on desktops, we went from PCMCIA cards to Express cards on laptops. And again, really what you're going to see these used for is if somebody has like an internal cellular card. That's usually what they'll be used for expansion. Memory. So memory for laptops, the key here that's different is we use SODIMM, small outline DIMMs. They're still DDR1, DDR2, DDR3, but they're just called SODIMM DDR1, SODIMM DDR2, or SODIMM DDR3. This is just like upgrading a desktop. The only difference is when we did our desktop, we inserted it at a 90-degree angle, right? Straight up and down, perpendicular to the motherboard. With a laptop, you have to come in like you're seeing here in this photo. We come in at a 45-degree angle and then push it down into place so it lays flat. And you can see that here. We've come in at a 45-degree angle and then it lays flat on the board. The reason why is a laptop simply doesn't have enough room for it to be sitting at a 90-degree angle. So we come in at 45 and then clip into place. The big difference here is you'll have these metal clips on the side that will hold it in place. Before we had those plastic wings that came up and grabbed the plastic tabs on desktops. Here, they clip into place with those silver springs. If you want to take it out, you open those silver springs. This card will flip back up to a 45 position and you can slide it back out. Other than that, use the same ESD precautions, remove power from the laptop, unscrew the cut casing of it, and put the laptop memory in. Your motherboard will still determine how much and how fast that memory will be. Another way we expand things, and the most common way we expand things with a laptop, is USB ports. Works just like a desktop. The only difference is a lot of times laptops won't provide as much power through the USB ports, and the reason why is we're trying to conserve battery life. If you have a device like a CD-ROM or an external hard drive that requires additional power to power the device, you can actually use two USBs with a Y adapter instead of one. And so it'll take both the cable will come out and in a Y out. One will serve for data and one will serve for power. And that will give you the additional power to run those. As you see on my laptop right now, I'm using USB for my microphone. I'm using it for my clicker pointer thing. USB is very, very common for laptops. Flash memory. So we talked in the storage lesson, the other storage device lesson, about flash memory cards. A lot of laptops will have built-in card readers for that. If you look at the side of my laptop, I have an SD card reader built into mine. Some laptops like this one has an SD card reader and a Memory Stick Pro Sony card reader in it. Some will have 2 or 3 different kinds. It depends on what you have. If your laptop doesn't have it and you need it, what can you do? Get a USB external one, just like we talked about back in the storage device lesson, and it'll let you read those memory sticks that way. Hardware device replacement. So we have a lot of components on our laptop that may break and may need to be replaced. Components such as our displays, our keyboards, our network cards, and our system boards can be purchased from the original manufacturer. So if you have an HP laptop, you'll go to HP to buy it. Other things like hard drives, CD-ROM drives, optical drives, CPUs, you can buy them from anybody. You don't have to buy an HP hard drive to put into a laptop. You can go buy a Samsung hard drive. It doesn't matter. They'll work similarly. The big thing though is you always want to remember what we call the 50% rule. And this is just like if you had an old car, right? You take it to the mechanic and they go, hey, your old car needs a new transmission. The car's worth $1,000 and they're going to charge you $2,000 to fix the transmission. What would you do with the car? You'd throw it away and buy a new car, right? You wouldn't pay $2,000 to fix a $1,000 car. Same thing with laptops. It's gotten to the point where laptops are so inexpensive now that most of the time it's not worth fixing unless it's a cheap fix. So, sometimes it's easier just to replace the machine than it is to buy the parts. If you have a cracked screen on a laptop that you paid $200 for, go buy another $200 laptop because the screen's probably going to cost you $150 to replace. It's just not worth it. The way laptops are powered, we power them using internal batteries and the AC adapter. So we don't have a power supply like we do on a desktop. In fact, the power brick that connects between your laptop and the wall, it does the transformation for you. It comes in as AC power, it transmits it or transforms it down to DC power, which then goes into your battery of your laptop, and then the battery charges the laptop itself. When you're getting AC adapters, you'll notice that sometimes they're rather expensive to buy from the manufacturer. Apple is notorious for this. If you want a new power supply, power adapter for your MacBook, it's about $65 to $75 for one of those. And you'll find third-party ones for $15 or $20. They're not made by Apple. The problem with this is sometimes they can mess up your machine and sometimes they don't work as well. So be careful with third-party ones. Buying the brand name on this is generally a good idea. Unique components for a laptop. We have a couple of unique components. As far as internal cards go, we can't fit PCIe cards in there. So instead we use mini PCIe. They're small, and they're about this big right here. Usually they're used for wireless cards or for cellular cards. It's pretty much the common ones. The other unique components of a laptop will be something like a touchpad. You don't have a touchpad to use as your mouse on a desktop, but on a laptop, that's primarily what we used. Some of them actually have a pointer system where it looks like a pencil eraser in the center of your G and H key, and you use that with your finger to move your mouse around. So laptop displays, we talked about these a little bit back and we talked about displays. So LCDs, again, that's a liquid crystal display, which uses a compact fluorescent backlight, gives you an active matrix display using the transistor for every dot. If you have something like a 1280 by 1024, which is a very common laptop resolution, you have over 1 million transistors or 1 million dots that are lighting up to make up that screen. You're going to use that compact fluorescent backlight to create your image. If that backlight dies, your image on your screen is going to be extremely dark where you can hardly even see it. And that tells you need to replace that light bulb. They die after about 3 or 4 years generally. So if you have an older laptop, that can happen. LEDs, they use an LED backlight instead of a compact fluorescent backlight. And again, if that backlight dies, you'll have to replace it. OLED, this is an example of an OLED. You can see how you can, on the bottom, you can see through the screen to the paper behind it. This is organic LEDs that are used, organic compounds between the electrodes to emit the light. Again, they're a prototype unit, not highly used. And then laptops don't use plasma because plasma is so heavy, but we do often use a plasma TV as an extra display for our laptops. So with our laptops, we have several issues that we can experience. The first one is what's called the contrast ratio. And the contrast ratio is what is the difference between the lightest light and the darkest dark. And if you look at that, that's what the ratio is. The higher the contrast ratio, the better your display is going to be. The other thing we want to consider with our laptops is our viewing angle. And what that means is when I'm looking at my laptop right now, I'm straight in front of it, so I'm at 90 degrees. But if I come off to the side and I'm looking at it from over here, now I'm at like 130 degrees. Laptops, depending on how good the display is, they'll either be visible straight on only or at a narrow viewing angle, maybe within 10 or 20 degrees of straight on. If they're a high quality display, you might be able to see it as far away as 170 degrees. So you're almost to the side of the display as still being able to see it. It just really depends on what quality you have. And again, that can be a security issue for you because if you're on a plane, you don't want the guy sitting next to you to see your screen, right? So you may want to get like an anti-glare screen or a security privacy screen for that. We talked before with LCDs and LEDs, they have native and scanned resolutions. Every display has its own native resolution. Everything else is either scaled up or scaled down. And then there's a component inside your laptop called the inverter. And we talked about the fact that your power adapter takes the AC from the wall and converts it to DC for your laptop to use. Well, your monitor in your laptop, it wants AC power. So there's an inverter that takes that DC power and transmits it back to AC to run the display. So we're converting this power back and forth several times. If that inverter goes bad, your display will not light up. Okay? And this is a very common part that needs to be fixed or replaced on laptops. Again, usually around that 2, 3, 4 year point is when they'll fail. And you can see in the hand here, we're holding an image of one. They're very small devices. They don't cost very much, usually about $20 or $25. So if that's the problem, it's a cheap fix. But if it's the actual display itself, that can cost a lot more money. So some special features. When we look at a laptop, we can have special keys on our keyboard. You can have things like the volume controls, the brightness control, the on and off for your wireless networking. Some of your keyboards are backlit, so you actually have light behind the keyboards. If you're working in a dark plane, you can see your key letters. You'll have on and off keys. You'll have the connect to the external monitor screens, contrast adjust, all these type of things. Usually uses what we call function keys, where you'll hit a function and then like the F1 or the function in the F2, and that'll make it brighter, lower, things like that. The second thing with laptops is they always have the dual display capability because you have an internal laptop screen already, and then usually you have either a VGA or an HDMI port that allows you to give the image to the secondary monitor. We can do this with either a clone or mirror display or an extended display. Just like we talked about with my laptop, I'm extending it from my screen onto your screen that you can see on the projector using that dual display capability. Alright, another big question that always comes up with laptops is the way you expand through either a port replicator or a docking station. So a port replicator, what it does is it connects cables to a separate device instead of to the laptop. A good example of that is on the bottom right corner. So why this is useful, I'll give you a great example. My aunt, she's a realtor, and so she lives on her laptop. And so when she comes to the office, she doesn't like having to use her small screen on the laptop or the small keyboard of the laptop. So she's got an actual desktop monitor. She's got a desktop keyboard and mouse. She's got her printers and all that stuff. But every time she'd come into the office, she had to hook all these cables up to her laptop, and it takes time. With a port replicator, she hooks all the cables to the port replicator, and only one cable goes from the port replicator to her laptop. So it's very easy to plug and unplug. The thing with a port replicator is that it does what it says. It replicates ports, meaning whatever ports are already on your laptop, that's what you're going to get on a port replicator. It doesn't give you any additional features. A docking station, on the other hand, which I'm showing you here on the left, it's going to add features for you. So, with the docking station, what happens is I take my laptop and it has a specialized port, like this is an HP or a Dell port replicator. And when I put my laptop into it, all the data from this port replicator, from this docking station, will go to and from the laptop through a bottom connection on it. And you'll notice that it has lots of USB ports. It's got a modem, it's got Ethernet, it's got video displays, it's got audio, it's got printers and serials and charging ports. It's got all sorts of different stuff on this port replicator that the original laptop may never even have had. So my laptop, for instance, has 2 USB ports and a mini display port. If I used a port replicator, I'm going to have 2 USB ports and a mini display port. I'm not going to have anything else. Some of these port replicators will, some of these docking stations will even have things like a Blu-ray disc in it, or they'll have a DVD disc in it, or an external hard drive in it. All the stuff of these can be added to this as extra features, giving you extra capability. So remember, port replicators, same ports you have on the laptop, just in a single combined interface. Docking station, it's going to give you additional capabilities to that laptop. So here's an example question. In reference to the express card types, you have express card 34 and express card 54. Which of the following best describes what the numbers indicate? Is it the size of the memory allocation, the IEEE specification it originated from, the size of the expansion slot, or the number of available communication channels? C, it's the size of the expansion slot, right in millimeters.